Hi class, welcome to Wednesday's lesson. Hope you had a good 2 days. I posted the video lesson on Monday. I hope everybody was able to listen and view the lesson. It was the first lesson on electricity, and today we're going to be continuing where we left off and continuing with the static electricity. So today we're looking at electric charging. Okay, so how does charge build up in an object? We are going to be looking and identifying the three different methods of charging. So we're going to be looking at charging by friction, charging by conduction, charging by induction. These are the three methods. And then we're also going to be defining and describing induced charge separation. So first method of charging is charging by friction, and this is basically a process in which neutrally charged objects, so objects that have no charge, equal positive charges to negative charges. When they're brought together and they're rubbed against each other, they produce an opposite electric charge on each other. Okay, so for example, in this diagram, you see on the left-hand side, you see two objects, and they are both electrically neutral. Okay, so you have the hair, which is neutral. It is an overall net charge of 0, because there are 1, 2, 3, 4, 5, 6 negative charges and 1, 2, 3, 4, 5, 6 positive charges. So neutral, net charge of 0. The comb is also neutral. 1, 2, 3, 4, 5, 6 negative charges compared with 1, 2, 3, 4, 5, 6 positive charges. The overall charge is 0. Okay, so when you look at the second diagram here on the right, you will see that as that comb has been brought and basically pulled through the hair, there's friction. They're rubbing, the two materials are kind of being rubbed against each other. The hair is left with more positive charges compared to negative charges. So 1, 2, 3, 4, 5, 6 positive compared with 1, 2, 3 negative charges. So the hair becomes positively charged after the rubbing. And the comb has 1, 2, 3, 4, 5, 6, 7, 8, 9 negative charges compared with 1, 2, 3, 4, 5, 6, only 6 positive charges. So the plastic comb has become negatively charged. The hair has become positively charged. Okay, and how do we know why the comb becomes negatively charged and the hair becomes positively charged? Why is it not the opposite? Well, many investigations have been done by scientists, and they have been able to, over time, make a list of materials based on their ability to hold on to their electrons and their ability to lose electrons. And this is known as the electrostatic series table. And I'm going to be talking about that with you in the next lesson. So this shows you charging by frictions, whereas after rubbing, one material or object becomes positively charged, whereas the other one becomes negatively charged. Then we have charging by conduction. And charging by conduction is basically a process in which a charged object, either positively charged or negatively charged, is brought into contact with a neutrally charged object, so an object that doesn't have any charge. And this results in basically a sharing of electrons and each having the same charge. So, before we go any further with charging by conduction, I'd like to talk to you about the detection of charge. Like how do scientists detect charge in the first place? Well, there's many different devices and tools, but the one that we talk about in grade 9 science is what is known as an electroscope. And scientists have come up with this design and designed it to be able to detect the presence of charge. The two that I'd like to talk about are the metal leaf electroscope, so this one on the right hand side, and then the pith ball electroscope, which is going to be on the next slide. So in the metal leaf electroscope, the design looks like this. You have a metal ball at the top, and then it is basically eventually connected. This is also metal, different types of metal, but connected to two very thin metal strips. And these metal strips are enclosed within you can't see it in this diagram, but basically they're glass on the outside. So you can see through this electroscope. And basically what we want to see is how these metal strips behave. When we're using a metal leaf electroscope, we're basically looking at those two metal strips and how they behave. So in a neutral electroscope, you have an equal number of positive charges as negative charges. So here again, we have 1, 2, 3, 4, 5 negative charges, 1, 2, 3, 4, 5 positive charges. The leaves have the exact same. 1, 2, 1, 2. On this side, 1, 2 negative charges on this side, and 2 positive charges on this side. So electrically, this metal leaf electroscope is neutral. So what happens in order for you to detect the presence of charge? So you bring something that's charged close to that metal ball. And this is a negatively charged rod, for example. So there's a lot more negative charges than positive. When you bring that rod close to that metal ball, the electrons, because we know that they can move, they will move away from that negatively charged rod, and they will move down the electroscope into the metal leaves. And what happens is that these leaves become negatively charged because there are now 1, 2, 3, 4 negative charges compared to 2 positive. And here you have 5 negative charges compared to 2 positive. So both leaves become negatively charged. And we know from the law of electricity or electrostatics is that 2 negative charges will repel each other. And that's what happens. The leaves will separate. And that's how we detect the presence of charge. Okay? And the same thing will happen if you bring a positively charged rod close to this metal ball. The only thing that will happen differently is that instead of the electrons that would move down into the metal strips, the opposite's going to happen. The negative electrons will move up towards the metal ball, and because they are attracted to this, if this was positively charged, they would be attracted to it, okay? Leaving these strips more positively charged. And when you bring 2 positively charged objects close together, they will repel each other. So the same thing would happen. So if an object is neutral, the metal leaves will hang straight down like this. But if the object this object right here, is either positively charged or negatively charged, the metal leaves will spread apart. And that's how we know that there is charge present when those metal leaves will spread apart. The second type of electroscope is known as the pith ball electroscope. And this right here is the pith ball. It is basically made up of styrofoam, and it is coated with a conductive paint. And it is suspended from a piece of string, very simple design. This is a metal bar, basically a metal bar and connected to a base, okay? And what happens when you have a neutral pith ball electroscope, that ball will just dangle and just lie, basically it will be straight. The string will be straight like that. Because there's equal number of positive charges as opposed to compared with negative charges. Okay, this is what happens and what it looks like when it's neutral. When you bring this negatively charged rod close to that neutral pith ball, the electrons in that pith ball are going to move all the way back, away as far as they can, because electrons are the ones that can move. They can't escape, but they can move all the way back to the back of the pith ball. And now what happens is that this side of the pith ball is going to be positively charged. And eventually, because that side is positively charged, it will be attracted to that negatively charged rod, because opposites attract. Eventually, contact will be made, okay? And once the contact is made, these electrons in the rod, which are attracted to that positively charged side of that pith ball, they will move, they will transfer into the pith ball. So making that pith ball overall negatively charged. Now, when this pith ball becomes negatively charged and it's close to that negatively charged rod, opposites attract, but like charges repel. So these will repel each other, and the pith ball will move away from the negatively charged rod. Now, in class, in our science lab, we have these electroscopes, the metal leaf and the pith ball electroscopes that we use during our labs in electrostatics. But unfortunately, we're at home and we can't use them. You can make some of them if you have the materials at home, especially the metal leaf electroscope. There's lots of YouTube videos if you would like to make one and play around with it. But this is what they're used for. They're used for the detection of charge. Okay, going back to charging by conduction. So charging by conduction is where you eventually have a contact being made by something, and there's a transfer of electrons. Okay, so this negatively charged rod is brought close to this pith ball. There's contact made, and the electrons from this negatively charged rod will be transferred into this pith ball, eventually making this pith ball negatively charged as well. So this is still negatively charged over here because not all of the electrons are gone. Some of them left and went into the pith ball, but the pith ball now is more negatively charged. And then you have this separation. You have this repulsion where the pith ball will move away from that negatively charged rod, and that's called charging by conduction. So charging by as a result of the contact made and the transfer of electrons. A third type of charging is called charging by induction. Charging by induction results from bringing a charged object close to a neutral object, but making no contact, so no touching. The electrons therefore cannot jump from object to object, resulting in an induced charge separation. So it's basically a temporary charge situation. This is an example, and I apologize, this is kind of a bit blurry. I got this, I guess it's not even the good size, but this is a positively charged rod brought toward this. This is a neutral sphere. If we count all the charges, we should have the same number of electrons as protons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So, same number of charges, but when you bring a positively charged rod toward that neutral object, the electrons that can move will move towards that positively charged object. So this is basically inducing a charge. Okay, there's a charge separation here. Overall, this object is still neutral, but this side is going to, the side that's closest to that positively charged rod is going to be more, negatively charged, and the side that is away from that positively charged rod is going to be more positive. Okay, so this is called charging by induction. If you take away that rod, this will, the electrons will kind of scatter themselves around more evenly again. Okay, and that's what charging by induction is. So induced charge separation is the movement of electrons in a substance caused by the electrical field of a nearby charged object without direct contact. That's why the electric field of objects is very important for this whole concept of electrostatics. And that is the end of this PowerPoint lesson. I will be posting reading and homework for this lesson, and if you have any questions, please feel free to post on the Google Classroom or email me privately. Okay, have a wonderful day, and I will talk to you again on Monday or Tuesday, I guess.